Then let's try to find the direction angle. So let's first find the cosine theta. Cosine theta is equal to the x component of this vector divided by the magnitude. The x component is the 11 over 2. So you have the 11 over 2 divided by 11 over 2 times root of 2. So now this 11 over 2 and this 11 over 2 cancel. So you have the 1 over root of 2. Then you rationalize this denominator. You have the root of 2 over 2. So when we first find one acute solution for this equation, cosine theta equal to root of 2 over 2. So that is a arc cosine root of 2 over 2. We know this is equal to 45 degrees. To determine the direction angle of this vector, you need to draw this vector. So we know this is the 11 over 2 and the negative 11 over 2. So 11 over 2 positive, negative 11 over 2 negative, so it's part of here. Right? So actually, the direction angle is this guy. So we know this is equal to 45 degrees. Then this direction angle theta, that should be equal to 360 degrees minus 45 degrees. And this is equal to 315 degrees. So now we get the direction angle is equal to 360 degrees minus 45 degrees, which is the 315 degrees. Then down. Now let's look at the problem 80. In the problem 80, for each given pair of the vectors, find the magnitude and the direction angle for the resultant. So now let's look at this. We have these two vectors. We need to find the resultant, okay? Find the magnitude and the direction angle of this resultant. We know the resultant is just the sum of these two vectors, right? And let's first get the component form of these two vectors. And we call this vector A. So this is the vector A. And its component form, let's see, and this is a negative 5 and then negative 4. So vector A is equal to negative 5 and negative 4. And we call this vector B. So the x component of this vector is equal to 6. So this is 6. And the y component is equal to negative 2. So negative 2. Okay. Now, let's go to the whiteboard. So this is the page 612, problem 80. And we have the vector A equal to 6. So we have the vector A equal to negative 5 and negative 4. Then vector B equal to 6 and negative 2. Now we need to find the sum of these two vectors. So A plus B, we just add their components. Then we have the negative 5 plus 6. And this is the first component of this resultant. And then negative 4 plus negative 2. And this is the second component of this resultant. And then we simplify, we get the 1 and negative 6. So now we can find the magnitude of this resultant, this sum. So this is equal to square root of 1 square plus square of -6. And then, this is equal to 1 plus 36. And this is equal to square root of 37. Now, let's get the sine theta, okay, sine of this direction angle. We know the magnitude is equal to root of the 37, right? And the y-coordinate of this vector is equal to -6. So first, we can find the arc sine of this -6 over square root of 37, and this approximately equal to -80.54 degrees. And you go back to the graph. So when you add this two, finally you get the 1 and -6, right? So this point, this terminal point of the resultant is in the quadrant 4. So quadrant 4, so it's about here. Actually, this is the resultant of these two vectors, right? So the direction angle, that should be this guy. And now we already found this angle. This is equal to -80.54 degrees. Then to find this direction angle, we just use the 360 degrees plus this -80.54 degrees. Then we got the direction angle of this resultant. So let's come back to the whiteboard. So the theta direction angle is equal to 360 degrees plus this -80.54 degrees. And then we get 279.46 degrees. And then we find this direction angle.